Good morning, dear students. Final year physics students of our Chambers College. Today, I am going to discuss our 5th semester 6th paper, Modern Physics. So, modern physics means the physics in the 20th century. During 19th century, the physics is called as classical physics. In 20th century, so many discoveries were made like lasers, computers, digital electronics, microprocessors, atom bomb, etc. are all discovered in the 20th century. That's why this physics is called as modern physics. In this modern physics, our first unit is atomic and molecular physics. Atomic and molecular physics. Atomic and molecular physics. Before going to the chapter, we must know the meaning of this title, atomic and molecular physics. We know that elements are made of atoms. That means the smallest particle of the element is atom, but molecule is a group of atoms. That is, hydrogen and oxygen are atoms, but O2 is a molecule and H2O is a molecule. So, in this chapter or in this unit, we have to discuss about the atomic structures and different characteristics of the spectra, either atomic spectra or molecular spectra. So, before that, in classical physics, atom is indivisible. Later, electron was discovered. Its charge is negative. Electron is the constituent particle of an atom. But atom as a whole electrically neutral. Atom as a whole electrically neutral. So, it is expected that there is some positive charge which, in order to balance this, the negative charge of the electrons in the atom. Later, the electron charge was discovered by Millikan. In order to determine the charge of the electron, Millikan did this experiment and repeated this experiment at about 20,000 times. Also, the specific charge means E by m, charge per unit mass. The specific charge of the electron is determined by J.J. Thomson. So, knowing the value of E and E by m, we can estimate the mass of the electron. The mass of the electron, E by m. It is found that the mass of the electron is only 1 by 2000th of the hydrogen atom. So, the entire mass of the atom is due to the positive charge. The discovery of positive rays. The discovery of positive rays is helpful to J.J. Thomson to find the value of this E by M. So, different atomic models were proposed in order to explain the spectrum of different atoms like hydrogen or the mercury spectrum or etc. So, the different models are, the first one is Thomson's plum pudding model or custard apple model. The second one is Rutherford's nuclear model. And the third one is Bohr atomic model. And the fourth one is Sommerfeld relativistic model. And the fifth one is vector atom model. And the sixth one is wave mechanical model. So, you may have a doubt what is the need of these 6 models. Any single model is just enough to explain the structure of the atom. But in order to overcome the failures of the previous model, a new model was proposed by different scientists. So, as per our syllabus, we have to discuss about Bohr atomic model. As we see in the board in our campus, the Newton's caution, no discovery was made without a bold assumption. Like that, here the Bohr model, atomic model, also depends upon, or the Bohr atomic model proposed by some assumptions. So, in order to explain the spectrum, these models are proposed. So, the assumptions made by Bohr are the electron. The first one is the electron revolves around the nucleus in circular orbits. The electron revolves around the nucleus in circular orbits. These orbits are also called as stationary orbits. Why? Because as long as the electron revolves in this circular orbit, it cannot radiate energy. That means it cannot lose its energy. So, in Rutherford's stationary model, the previous atomic model is Rutherford's stationary model. In that, he proposed that the positive charge is located at the center of the atom and the electrons are fixed at a constant distance on either sides of the nucleus. But the force of attraction between the nucleus and the electron is 16 times greater than the force of repulsion between the two electrons. So, this leads to the collapse of the atom. So, in order to avoid this difficulty, Bohr proposed this circular orbit. So, his assumption is, when the electron is revolving in its orbit, it cannot radiate any energy or electromagnetic energy. This is because, according to Maxwell's electromagnetic theory, the accelerated electron must radiate energy. Here, the electron which is revolving in the circular orbit possesses centripetal acceleration. That's why he assumed that the electron cannot lose its energy as long as it is revolving in that orbit. So, this orbit is called as stationary orbit. In this orbit, since it revolving in a circular orbit, there is some force of attraction between the nucleus and the electron. The force of attraction between the nucleus and the electron serves as centripetal force, and it is balanced by the centrifugal force, which is given by mv square by r. Therefore, the force of attraction is given by 1 by 4 pi epsilon naught into Ze square by r square, and the centrifugal force is given by mv square by r. So, these two forces are equal in magnitude and opposite in directions. So, the electron maintains, or the electron is in its orbit, in its fixed orbit. By using this expression, we can calculate the kinetic energy of the electron in that particular orbit. Similarly, since the electron is in the electric field of the nucleus, it possesses some potential energy. That potential energy is given by 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught into Ze square by r. The potential energy is given by 1 by 4 pi epsilon naught into Ze square by r. As we know that the kinetic energy is equal to half mv square, kinetic energy is equal to half mv square. The total energy of the electron is given by the sum of these two energies, and it is the energy of the orbit. So, this is about the orbit of the electron. So, here we have we have to explain how the spectral lines are formed, how energy is, when did the electron radiates energy. To answer this, when the electron jumps from higher energy level to lower energy level, it radiates energy. The amount of energy radiated by the electron is given by nh nu. Here, h is the Planck's constant and nu is the frequency. So, as long as the electron revolves in the stationary orbit, its angular momentum mvr is equal to nh by 2 pi, nh by 2 pi. Here, angular momentum means moment of momentum. Momentum is mv. Moment of momentum is mvr. As we know that moment of the force is equal to force into perpendicular distance. Here, moment of momentum is equal to mvr. The second assumption made by the Bohr is, as long as the electron revolves in its stationary orbit, the angular momentum of the electron is equal to nh by 2 pi. And the third one is, whenever the electron jumps from higher energy level to lower energy level, then only it radiates some energy, which is given by the equation E2 minus E1 is equal to NH nu. Here N is an integer and H is the Planck's constant and nu is the frequency of the spectral line. Frequency of the spectral line. So, by these assumptions, Bohr succeeded to overcome the difficulty of the Rutherford's planetary model. But there are so many drawbacks in this model. The drawbacks of this model are: one, even though this model successfully explained the spectrum of the hydrogen atom or singly ionized helium atom, the other facts relating to the spectrum were not explained by this model. The other characteristics of the spectrum are the fine structure of the spectral line and the intensities of the spectral line, etc. Fine structure means each spectral line consists of a group of fine lines. Fine lines means small lines. The reason for this is there are so many sub-energy levels in the principal orbit. Then only we can explain the fine structure. There is no such possibility in this Bohr model. And also Bohr model failed to explain the arrangement of the electron in an atom. Bohr model failed to explain the arrangement of the electrons in an atom. Also, the Bohr model failed to explain the chemical bonding. And also, Bohr model failed to explain Zeeman effect and Stark effect. So, Zeeman effect means the splitting of spectral lines into two or more in magnetic field. Similarly, Stark effect means the splitting up of spectral lines in electric field. These two are not explained by this Bohr model. So, these are in order to explain or in order to overcome the drawbacks of the Bohr model, another model was proposed by Sommerfeld. But the success of Bohr model is Bohr successfully explained the spectrum of the hydrogen atom. The spectrum of the hydrogen atom. Because the electron releases energy whenever it takes jump from higher energy level to lower energy level. In such a way, the energy radiated by the energy radiated by the atom or the energy released by the electron when it takes from higher energy level to lower energy level is given by the equation mu r, wave number, that is equal to 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. 1 by n1 square minus 1 by n2 square. If the electron jumps from higher energy level to first energy level, that is n1 is equal to 1 and n2 is equal to 2, 3, etc., we will get Lyman series. Similarly, if n1 is equal to 2 and n2 is equal to 3, 4, etc., we will get Balmer series. The Balmer series wavelengths are in visible region. That means the visible spectrum belongs to Balmer series. In Lennon series, it is in ultraviolet region. The other series are partial series, bracket series, and Fund series. That means if n is equal to 3, n2 is equal to 4, 5, 6, we will get partial series. Or n is equal to 4, we will get bracket series. And if n is equal to 5, we will get Fund series. All these series belongs to infrared region. All these series belongs to infrared region. So in this unit or in this chapter or in this topic, the drawbacks of Bohr model is very important for examination point of view. So in the next we will continue another atomic model called Sommerfeld model. In